and today I am here to show a project in which we will find out which shape is suitable for a parachute to land safely. First we find the areas of the two shapes. When we find the area of octagon, we get that the area of octagon is 196 cm square, and when we find out the area of hexagon, we find out that the area of hexagon is 93.53 cm square. Both the shapes have the same sides of 6 cm, and when we calculate the area, we find out that the area of octagon is more than the area of hexagon. Here area is more in octagon. But the person inside that parachute will shake when the area is more. That means there is jerk when the area is increased. Therefore, in this case, there is no jerk in regular hexagon. So the person can land safely to the ground. So we can see that when the area is more, the jerk is more. So the shape with the less area, which is the regular hexagon, is suitable for
Good morning everyone. Today I am going to show you a puzzle related to probability of cards. We all might have seen a deck of playing cards. It consists of 52 cards which are divided into 4 suits of 13 cards each. The clubs, spades, hearts and diamonds. As you can see, the clubs and spades are of black color and the hearts and diamonds are of red color. Each suit contains of face card, ace card and the number cards. The face card contains of king, queen and jack, and the number cards contains of numbers from 2 to 10. This is made for the visualization of playing cards and to know more about playing cards. I have made a few questions related to this. We will see one question related to this. A jack. The answer is 1 by 30. We will see how it is 1 by 30. The number of favorable outcomes, that is, a jack is 4 out of 52 cards. That is, each suit contains of 4 jacks that of 52 cards. P of E equal to number of favorable outcomes by total number of possible outcomes. 4 by 52. By we substitute this, we will get 1 by 30. We will spin this for the better visualization of this. Heart, king, queen and jack. These are the face card, and the ace card contains of a card which is written from alphabet A. The number cards.
Hi everyone, I am Anugraha of class 10D here to show you a project on how to find the area of a trapezium. We have a trapezium with parallel sides A and B. I am going to cut this trapezium horizontally by its half and going to rotate it. Now we got a parallelogram. I am going to take one end of the parallelogram, that is one triangle, and going to place at the other end. Now we got a rectangle. As we all know how to find the area of rectangle, length into breadth. Here the length is A plus B and the breadth is height by 2. So the area of trapezium is A plus B into height by 2. That is sum of parallel sides into height by 2. Thank you.
Good evening everyone. Today I would like to introduce you a project which I had made for a maths exhibition. The project is based on the topic or on the concept of probability. If we say more clearly, it is based on the topic of probability of cards. As we all know, a group of 52 cards make together a deck of cards or the pack of cards. Spades, diamond, hearts and clubs are the 4 types of cards, which contains 13 cards in each of them, making together a total of 52 cards. This is the project which I had made. As you can see that this is simply made up of papers. So we can just open it by unfolding it. Just turning it clockwise. So this is the one. As we can see, the method used behind in making of this project is called the spiral cube. As the name suggests, we can get it from the name that each cube is joined to the side of one another, making it a chain of cubes. It is called the spiral cube. So the intention behind the making of this project called the spiral cube or the chain of cubes is to catch up the concept of the probability in a more efficient and an easy way. This is made up of just simple papers, the one of the common material found around us. Using some of the paper crafts, also known as the origami.
Hi friends, I am Anupama of class 10D here with a small presentation. First of all, I want to tell something about the two birds, that is, one eagle and the crow. On seeing both of them, the crow is much smaller than the eagle in size, in strength and many other things. But the only bird that has the courage to fight against the eagle is crow. But the eagle won't respond to them and fly higher than, and they won't stay to fight against these crow. But the crow has the habit of stealing food from the eagle, and in return the eagle went to the crow's nest and eat all the baby crows. So the crow sit next to its nest to protect the baby crows from them. So here I have come with an interesting question from the Applications of Trigonometry chapter. So let's see. So here is the model of our question. It's about eagle beaks crow. Look at the question. An eagle is sitting on a vertical pole of 12 meter height. Opposite to that, a crow is sitting on a tree near to its nest of 4 meter height. If the angle of depression to the tree is 30 degree, then how much distance should cover the eagle to reach the crow's nest? This is our question.
So today I am going to share you how to learn trigonometric ratios of complementary angles and square identities within this normal hexagon. So the normal hexagon has sides written as sine, cos, tan, cot, sec and cosec. So we need a stick like this in one of its ends are written as theta and 90 degree minus theta. So I'm just going to place it over here. Then we can read itself with the formula sin theta is equal to cos 90 degree minus theta. If I turn it over this, you can read in this way. Cos theta is equal to sin 90 degree minus theta. I'm just going to bring it down. Cosec theta is equal to sec 90 degree minus theta. Similarly, sec theta is equal to 90 degree minus theta. So for the middle side, I am taking a larger stick and placing it over here. Tan 90 degree minus theta is equal to cot theta, and cot 90 degree minus theta is equal to tan theta. In this way, we can easily learn the trigonometric ratios of complementary angles. Now, square identities. As I have written 1 over here, we have to learn square identities in a triangular form, just like sine to cos, tan to sec and cos to cot. Remember, and note must be taken that on the upper side we have to add, and on these two sides we have to take the minus. Then the formula will come automatically, just as sine square theta plus cos square theta is equal to 1. Then sec square theta minus tan square theta is equal to 1. Cosec square theta minus cot square theta is equal to 1. In this way, we can learn trigonometric ratios of complementary angles and square identities. Thank you.
A warm welcome to one and all present here. Myself, Amina Jasmine of class 10D is going to exhibit a model of all the values of trigonometric ratios of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. We all are familiar with all the values, but also there will be some difficulties for us to remember all the values correctly. This is a joyful manner of learning all the values, and let's see how it works.
I have made a project for the Max exhibition. It is a hexagon with the trigonometric values inscribed on it on all sides. This has many uses. It can be used to memorize all the trigonometric identities and formulas in a very easy manner. For example, the first one is that you can memorize the complementary angles very easily by looking at the parallel lines. That is, sine into 90 minus theta will be equal to cos theta, tan into 90 minus theta will be cot theta, and sec to 90 minus theta will be cosec theta and vice versa. The second function is that the diagonally opposite angles will be the reciprocals of each other. That is, 1 by sin theta will be cosec theta, 1 by tan theta will be cot theta, 1 by sec theta will be cos theta, and vice versa. And another use is that this triangle, and this triangle, these three triangles are used in the trigonometric identities. That is, sec square theta minus tan square theta will be equal to 1, cosec square theta minus cot square theta will be equal to 1, and sin square theta plus cos square theta will also be equal to 1. These identities can easily be memorized using this hexagon. I hope that it can help you. Thank you.
Player will take the next chance, and if he or she gets the satisfied event, then she can play one more chance. If he or she doesn't get the satisfied event, then chance will be passed on to the next player. When we get all the desired events, the first person or the first player who gets the probability will get 1 point. Similarly, you can write as many questions as you want in this and play the game on and on.
Respected teachers and my dear friends, now I am going to show you how to find an object height using clinometer with some trigonometric ratios. So this is the clinometer that I have made, and I have fixed some tires for some movement purposes, and I have made it almost a type of structure of a car. So what we first should do is to keep the minimum vertical distance, and this is the object which I am going to find its height. So we should first keep the minimum vertical distance, and I have kept them in a 10 cm difference, and we should know the height of the clinometer, that is 30 cm. So now we should do is to look through this pipe to the top of the object that we are measuring, and as you can see, it is 45 degree. So using trigonometric ratio, that is tan 45, we already know that it is 1. We could find the height of the object. So I have drawn the situation in a page so we could know better. So this is the height of this is the clinometer, and this is the object. This is the height of the clinometer, that is 30 cm, and we should find the height of this object. So I have already told that the distance between the object and the clinometer is 10 cm, and this side will be parallel to this side, and this is the 45 degree, the angle of depression, and if we minus this small part from the total height of the clinometer, we will get the height of the object. So tan 45, which is equal to opposite by adjacent, which is opposite by 10. This is the 10 cm, that is the adjacent side, is equal to 1. So opposite side will be equal to 10 cm. So if we minus the total from the total 30 cm, the 10 cm, we will get 20 cm, which is this side will be equal to this side. So the height of the object is 20 cm. So this is one small example how we could find the height of the object using clinometer. So thank you.